how many numbers between 1000 and 10,000 can be formed using digits 0, 1, 2, 4, 7, 9, 8. Assuming repetition is not allowed. Now, basically, you're told you have to form numbers between 1000 and 10,000, okay, which can be formed using these numbers. So, how many numbers are there? 1, 2, 3, 4, 5, 6, 7. Now, if you notice all the numbers which lie between 1000 and 10,000, the first one will be 1001 and the last one will be 9999. Now, the total number that can be formed here are all 4 digits numbers. Okay? So you have 7 numbers in all and you have to take 4 numbers at a time. Right? So what will be the permutation? Number of permutation will be 7p4 or factorial 7 upon 7 minus 4 factorial 7 divided by factorial 3. Let's take this value as 1. Okay. Now if you see, when you use all the numbers, some of these numbers will also have 0 at the thousandth place. So let's say if you had 0, 1, 2, 4, then ideally this is not a number which lies between 1000 and 10,000. Why? Because this effectively becomes a 3-digit number. And this problem comes in only when you have 0. Had it been that instead of 0 you would have 5, this issue wouldn't have arisen. The answer would have been straight away 7 dash, 3 dash, and this one. Okay. So you also find out how many 4-digit numbers can be formed where 0 is there. So basically, let's fix 0 here. Okay. Now when 0 is fixed here, then basically your permutation of such numbers wherein you have 7 numbers, total are 7 numbers, one of them is fixed, right? But once your 0 is fixed, you are left with 7 minus 1 is equal to 6 numbers, right? And these 6 numbers have to be fit in 3 boxes, because this is a 4-digit number, so 3 boxes are left because 0 is fixed here. So out of the 6 number, you have to choose 3 numbers. So the permutation of this becomes 6p3 or factorial 6 upon 6 minus 3 or factorial 6 upon factorial 3. Right? So the total number which can be formed with these digits are total less numbers with 0 at thousandth place. Which effectively is 1 minus 2. So factorial 7 upon 3 minus factorial 6 upon 3. So if you take the LCM, you get factorial 3 as LCM, and this becomes factorial 7 minus factorial 6. Okay. Now this will become even more cumbersome, or we can just write this down as factorial 7 can be written as 7 into factorial 6 minus factorial 6 upon factorial 3. Take factorial 6 as common here, so you get 7 minus 1 upon factorial 3 can be written as 3 into 2 into 1. So this will be 6. 7 minus 1 is 6, so these two cancel out. So factorial 6, which is effectively 6 into 5 into 4 into 3 into 2. 30, 120, 360, 720. So the logic behind this one was that whatever is the number of permutations that you have, if there is a 0, then certain numbers, wherever 0 appears in the thousand place, become 3-digit numbers. So you need to exclude those cases.